Okay, let's take a look at this problem together. This is a A-B two-step process with processing time and setup time indicated here. Okay, so A is 1 minute per unit, B is 0.1 minute per unit, and setup time is 0 for A and 9 minutes for B. Okay, so without considering the batch size, the capacity which is essentially our mu, is basically 1 over processing time, 1 minute, 1 unit per minute. The capacity here is going to be actually 10 unit per minute. Okay, so potentially B is gonna be a lot more faster, but B has a setup time A does not have. So we're not quite sure how this setup time is going to impede or hinder the capacity of B. So let's take a look at each question here. And the first one is asking with a batch size of 5, right? What is the capacity of the process? So with a batch size 5, mu with a B equal to 5. Okay, so if you recall, the mu therefore is going to be 5 divided by setup time plus number of unit, which is batch size, multiplied by the processing time 1 here. Okay, so yeah, we got 1 here. Okay, this is the same with the capacity here because again, A does not have a setup time, so the calculation for A is actually a lot simpler. The capacity determination A is a lot simpler than that of B because of the setup time can potentially change things. So if you apply this, as you can see that B, even though it's capable of making 10 per minute, but because of this setup time, if you spread the setup time across all 5 units, your resulting capacity is going to be this much. It's much slower than A now. Okay. Yeah, this is the result for the first problem. Let's take a look at the second problem. Suppose they operate a batch of 15, and with this batch size, step A is the bottleneck. So I'm going to do similar thing again. B is, you're more than welcome to pause my video and try to do this yourself. Okay, understandably, A is still going to be 1. Okay, I know that you can just punch 1, but I'd like to do it using the formula. So batch size divided by amount of time it has involved in delivering 15, which in this case is a 0 minute setup time with a 15 unit each at 1 minute. Okay, so essentially this is your S plus BP part. Okay, still 1 here. This is still unit per minute. As you can see that capacity at B is a lot faster than now with much bigger batch size. Okay, so I think this reminded us one thing that we learned, one intuition we have learned from our class: the larger the batch size, the faster the capacity. Okay, but that is not the question from second part. What would be the average inventory after B? So basically, this is asking how much inventory is going to accumulate after B. Okay, so how do you interpret this question? How would you interpret this question? So so best way to interpret this question is you need to know what will be the maximum amount of inventory and what is the lowest amount of inventory that we take the average, which is Q over 2, but that is a general sense, okay? But because in this case, it will not be that simple because obviously you have a consumption rate, you also have a actual production rate. So if you recall lambda over mu, so we have like a lot of mu's here, and here. You kind of don't know which one to use, okay? So we need to determine the lambda in this case. Lambda when b is equal to 15. Okay, so how quickly things are passing through here, because this doesn't have this assembly process like the example we have used in class, that is somewhat more explicit in terms of how quickly things are being consumed. Okay, because it doesn't talk about any assembly process, somewhat more abstract in this particular case. But the speed at which things pass through step B is basically going to be your consumption rate or demand rate, because that's how quickly things are leaving B. Okay, so therefore in this particular case, the lambda of this particular system, okay, will be determined by the bottleneck in this case. Okay, bottleneck 1.40, 1.429. So obviously 1 is smaller, so the flow rate or consumption rate or pass-through rate of this particular system is 1. Okay, we have lambda, we have our capacity mu here, because this is basically your 1 over p part. So yeah, so let me just write it down here. Your fraction unconsumed is going to be 1 minus lambda over this guy right here. You can pause for a second and think about why I'm using that. It's basically 1 over p part. So your textbook is, I think according to your textbook formulation, it's lambda times p, but p is really nothing but 1 over capacity. So that's what I did here, 1 over capacity. Or I could have just done this, but it will lead to the same result. Okay, but this follows our formulation in the lecture note. So that's what that it's going to be the fraction unconsumed. But out of how much it is unconsumed? You recall, it is going to be out of 15. Okay, out of 15. By the time you're done making 15, how much would have passed through already? How much would have still remained there? It is 90% of 15 will still remain there. So that is basically your maximum inventory level is 15 batch size multiplied by 90%. Okay, therefore your average inventory level is basically half of that. So average inventory level after B is 6.75 units. Okay, let's talk about third one. What is the batch size that maximizes the flow rate of this process with a minimal inventory? So this is a batch size determination. However, this is not a batch size determination, but this is a case where you have a target capacity you want to match against. Therefore, not to be confused with the other case where you kind of have to determine the batch size based on, total production or total consumption, equilibrium quantity consideration. This is simply based on this equation right here. You want to know what is the capacity. In this case, we don't know what the B is, but we do know this is how you calculate it. S plus BP. Let me see if everything is correct, okay? Yes, this is correct. And what is our target capacity in this case then? So your target capacity in this case, let me remind you, your target capacity is going to be 1. You don't want to go faster than 1 per minute. You don't want to go any slower than 1 unit per minute, because this is somewhat constant. There's nothing you can do about the capacity of step A because it does not have any setup time. Therefore, you go back here, your target capacity is going to be 1. And we know this is a 9 minutes, and we know the P is going to be 0.1. Okay, so you kind of have to rearrange everything. It looks like it's going to be 10, right? So you're going to have to rearrange this like this. As you can see, if you move B, move 9, and your B is going to be 10. Your B is going to be 10. So that is the answer for this particular question. So I think this problem kind of reminds you that you kind of need to think based on what you have learned. It's not just oh, I have this equation or I have this formula, I can just apply it. You kind of have to determine how can you sort of synthesize everything you have learned so far and try to determine batch size and inventory level and all that. Okay, I hope this makes sense. If you have any questions, feel free to email me or message me. Thank you.